now. And we're going to go ahead and see them in terms of two variables. We're going to see our X and our Y. And then something is going to happen to my values that are going to allow me to graph and identify what's going to my graph, what's happening to my graph, okay? Now, I'm going to go ahead and define what two variable equations is first. So here it is. Two variable equations are two expressions equal to each other. So they don't have to be rational expressions anymore. So we can go ahead and finally see something else other than rational expressions. And contain two unknown variables. So we're going to go ahead and see what our two unknown variables are. Here are some examples. Y equals 3x plus 2. Y equals x squared minus 4. Y equals 2 to the power of x plus 3. We're going to go ahead and start seeing different types of functions now. 4x plus 7, y equals 14. And the last one, 3a minus 6b equals 9. We have our beautiful non-examples. X plus 4. Y plus 6 equals 3. And 3x is greater than or equal to 3. Okay, I'll let you guys copy this down. Our non-examples there. So we have x plus 4. We have y plus 6 equals 3. And 3x is greater than or equal to 3. Why are those examples non-examples? Go ahead and tell your beautiful neighbor. It's an expression. There you go. So it's just an expression. So it's not an equation. It's just an expression. All right, Andre, I'm going to let you pass it on. Daisy, I better Daisy. Or did I bet JC, sorry. Daisy, pick another one. We have y plus 6 equals 3 and 3x. Yes. Why is that one a non-example? There's only one beautiful variable. All right, Daisy, pass it on. All right, Lily. Why is the last one a non-example? 3x is greater than. There's no second variable. And what else? It's not an equation. So these more specifically, guys, if you guys remember, they are inequality. So whenever I have my greater than or equal sign or less than or equal sign or just my greater than or less than sign, those are what we consider inequalities. Okay, we are going to see them here pretty soon. So pretty soon. So those are going to be part of our beautiful games here that we get to put in our tools as items that we know. Okay. So with that said, good job, guys. We have our beautiful non-examples here. Okay. Now, like I said, we're going to go ahead and start with a series of two variable equations. Like we have here, there's some that have powers of 2, powers of 3, powers of 4, and so on and so forth. There's some that are exponents. So we have our beautiful variable inner exponents. There's some that are just linear. And we have other type of functions that we're going to be seeing so far. Different type of two variable equations that we're going to be seeing. Okay. Now, today we're just focusing on linear equations. Okay. So that's going to be our first parent function. Okay. Whenever I tell you about parent functions, it means that we're going to go ahead and see the basic of it, and then we're going to go ahead and see variations of it from there. Now, in order for us to analyze our beautiful two variable equations, we're going to go ahead and see the three forms, okay? My first form, you probably have seen this one. It's in slope-intercept form. Now, it's called slope-intercept because it's written in slope and intercept form. So we have y equals mx plus b. Now, my slope in this case is just my coefficient of the x variable. So this is my slope. My b is my y-intercept. So if I were to graph this beautiful equation, I would start with my y-intercept. And then from there, I would use the slope to create the next point. So my y-intercept is going to be where intersects my vertical axis, okay? All right, now, next item, we have it in standard form. Standard form is written in this way. We have AX plus BY equals C. A and B are coefficients. They're not variables. They're just there to represent that we have a coefficient. But in this case, they're going to be, whenever the examples are given with an actual value there, they're not going to stay as variables. They're now going to have a value instead of A or B, okay? And C is my beautiful constant, so that's why it stays on the right side, okay? And the last one, I'm pretty sure you guys have seen this one. This one is called point slope form. And this one, the last one, mainly it's used to write an equation whenever we're given a point and a slope. So whenever we have a slope, we can go ahead and determine where our next point is if we're given 1 point. If we're given 2 points, we can go ahead and determine what the slope is, and we can use one of those points to then determine what the equation is, okay? So we're gonna go ahead and use all of those informations here. So my last one, we have a point. So this is my Y component in my beautiful point. And my beautiful slope is my beautiful M. So it continues to be my slope. Okay, all right. So we have my beautiful components, my coordinates. We have my X sub 1, my Y sub 1, and then I have my beautiful slope there. Not too bad, huh? Now, my standard form, notice here that I have AX plus BY. It's just written in standard form since both X and Y are on the right side of the equation. Okay, listos. Everybody has this? No? Okay, I'll let you guys copy this down. Ah, yes, copy it down. To our next topic or our next section, which is called constant rate of change. Now, constant rate of change, guys, you've seen it before. I hope you have. If not, here in physics, are you guys taking physics yet? Yes. All right, constant rate of change. Now, constant rate of change basically is where the change happens in our beautiful Y value and our X value. Now, it's going to be so that I have a slope or sort of a rate of change happening on my graph. So let me go ahead and graph it so you guys can see it very quickly. So imagine that I have a graph like this. And in my graph, I'm going to have a line that goes, I don't know, like that, whatever one up, okay? Now, I'm going to go ahead and select some parts of it. So from here to here. And I'm going to go ahead and try to make a straight line much as possible so that I'm able to create the rate of change between this point and this point, okay? Now, that is what we call also, or we know it as our beautiful slope. So that rate of change, we're going to go ahead and use it as our slope, okay? Now, Ms. Vasquez, how do we do a slope? Well, if we have the coordinates, we can go ahead and find the slope as we usually do. Here is our beautiful equation. We have our 2 points, our X sub 1, Y sub 1, X sub 2, Y sub 2. We have our beautiful points here. Now, let me go ahead and fix my beautiful equations just very quickly, guys. And I don't want you guys to be confused. For some reason, Ms. Vasquez forgot to change her coordinates. It is Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1 as your rate of change, okay? So that's how we've been presented to us. Could it happen where we can go ahead and change it? Yes, we can. That depends which direction we want to go. Now, in physics, you're going to go ahead and see this notation. Your delta. So delta means that I'm going to go ahead and have a rate of change or a change in a direction. Now, the change in direction in my Y axis and a change in direction or the distance in my beautiful X, okay? So another way that you're going to see this in another format would be my delta Y over my delta X. And it's going to represent my slope here, okay? Now, we're going to start with linear equations, two variable linear equations. So we're gonna go ahead and just practice again our algebra 1 so that we can go ahead and apply it to the next parts. Let's see when the pass comes back. Okay, everybody has this. Yes. Okay, perfect. All right, so let's go ahead and apply it to our beautiful algebra 1 skills here. We have 2 points. We have -4, -1, and 4, 3. So here's -4. -1 is down here. Next point is +4 and +3 right here. Let me go ahead and graph. Did I give you guys graphing paper? Okay, make sure you guys write this down on your notes so I can go ahead and give you guys graphing paper now. So here are my beautiful points at -4, 1, and 4, 3. Now, what we're gonna do is that we're gonna go and apply our beautiful rate of change in that particular section of those 2 points, okay? We're gonna go ahead and create a straight line because that's the closest or the shortest distance between those 2 points. So I'm gonna go ahead and write now my beautiful slope formula. I have my slope. I know that my 2 values are going to be subtracting each other, and now I'm going to identify each point. Now, my first point, -4, -1, I'm gonna go ahead and make that one as my x sub 1, y sub 1. X sub 1, y sub 1. My second point, 4, 3, I'm gonna make this one as my x sub 2, y sub 2. So x sub 2, y sub 2. Okay, now my equation said that I was going to subtract which value to which value first. Y2 minus y1. So y2 is 3 minus y1 is -1. Then it's x2 minus -4x1. Okay, now remember that we have our additive inverse, which means that I change and I flip or change, or I have no idea how you guys do it. Keep, change, and flip, keep, change, and flip. I've heard it as keep, change, change, keep, change, change, or keep, change, flip. However we know it. We make sure we apply the additive inverse property, okay? So we have 3 plus 1 is 4. 4 plus 4 is 8. So therefore, simplify my beautiful slope. It'll be 1/2 in this case. And we can go ahead and verify it. Remember that my slope is also rise over run. If I rise, it's positive. If I fall, it's negative, and I always want to run to my right. Now, which point do I start from, Ms. Vasquez? You can go ahead and start from either point, but I prefer to start from my furthest to the left. If I start here, in order for me to go to the next point, I need to rise. So I'm gonna go up 1, 2, 3, and 4. And I need to run how many spaces to my right? 8. 1, 2, 3, 4, 5, 6, 7, and beautiful 8. So therefore, check. I have my beautiful slope done correctly. I did it. I inputted all my values correctly, properly. Okay, not too bad, huh? Do you guys want to try one on your own? Okay, let me go ahead and clear. Let me save and clear again. We're starting from the basics. Go ahead and try this one. -2, 6, 2, and 3. Remember that we have our beautiful slope formula, equals y2 minus y1 over x2 minus x1. Let's see what you guys get. -6 and -2 +6 right here. And +2 +3. Let me go ahead and create that beautiful line. Now, whenever I do that, I'm going to go ahead and fall this time. How many steps? 1, 2, and 3. So therefore, I have my -3. I'm going to run to my right. 1, 2, and 3, and 4. So we have it check marked. Raise your hand if you got that. Woo-hoo. Okay. We're taking a little break here, a little mental break. Okay. All right. Now, what if it's presented to us in a graph? Can we determine what our beautiful slope is? Yes, there's several ways in how to determine what the slope is. One of them is by picking 2 points on the line, whichever point you want. For example, this one right here, like -2, 0. And this one, 0, +1. And we can go ahead and find the slope there, but there's a much easier way. What would be another way to find out what the slope is? Go ahead. What would be another way? Y equals mx plus b. That's if we were to graph it. We're not graphing it. It's already graphed for us. Rise over run. All right, so I'm gonna go ahead and pick this point right here and this point right here. This is 1. Let's see. So from here, how many steps did I go up? It looks like 2, but it's going by 1. So it's what? 1. And then how many steps do I go in my run? I go 1 and beautiful 2. So this is 1 over beautiful 2. Not too bad, huh? You can go ahead and check by taking the coordinates and substituting everything into your beautiful slope-intercept form. And your slope formula. All right, go ahead and find the slope of this one. We have our beautiful values. This time it is going by 1 set, guys. So we have 1, 2, 3, 4, and 5. This one is 1, 2. And all the way up to 5, 6, 7, and 8. Okay. So go ahead and find what your beautiful slope is. Okay, so who went last? Lily, Lisha, pass it on. No one is ready. Andres? A ver, Andres. So help me out. Let's go ahead and identify our beautiful slope. So which way do you want, or which method? Do you want to get the coordinates and then do the substitution, or you want to do rise over run? Okay, perfect. Whichever way. Rise over run. Now, rise over run, remember that if I go up, it's positive. If I go down, it's what? Negative. And I always want to go to the right. So I'm going to go ahead and start with the furthest point to the left. So which one's the furthest point to the left? -1, 0. Okay. So from here, where do I go? Down how many steps? 1, 2, 3, 4, 5, and 6. So therefore, my rise is going to be what? -6. Now, how many spaces do I run to my right? 1, 2, 3, and beautiful 4. So 4. So what is my slope? Let's go ahead and simplify it. 3 over beautiful 2. Raise your hand if you got that. Let's go. All right. Okay, let's go on to our beautiful equations now. So we can go ahead and identify the slope now from the equations that are given, okay? Now, we already have this. Okay, now I'm gonna go ahead and go on to our next example, 4A. This one says right here, find the slope of the line given by, and we have 4x minus 2y equals 16. Now, go ahead and tell your neighbor, what form is this beautiful equation written in? What form is it written as? You can get the intercepts from it, but there's a more specific way. Wow. All right, Joaquin, what form is it written as? Standard form. It's written in standard form. Notice that my X and my Y are on my left side. Therefore, I need to modify it or rewrite it so that I have it in slope intercept form. Why do I want it in slope-intercept form? Y equals mx plus b? Because I can easily identify the coefficient of x and therefore be able to identify my beautiful slope. So how do I isolate? Because notice here that I have to isolate my beautiful y. What's happening to my y? I'm multiplying it by -2, and guys, I need it quiet, please. And I'm adding 4x, so my inverse would be 2. Subtract 4x on both sides. My left side has to be now -2y equals, I'm going to rewrite this so that my x value is first. So -4x plus 16. Now, my last step is going to be to divide everything by -2. The reason being is because I want to continue to isolate that beautiful y. So now that I've isolated that y, I have y equals -4 divided by 2 is positive 2x. And 60 divided by -2 is beautiful 8. Now that I've rewritten it in this form, I can go ahead and easily identify my beautiful slope. And what is my slope? Not 2x, just the coefficient of x, which is beautiful 2. Or 2/1 once we graph, okay? X is not part of the slope, it's just the variable that it's accompanied by it, okay? So that's how many times we're gonna go ahead and multiply the slope or produce it, okay? For today. So go ahead and try this one. All right, so what do I do? Quickly, guys. Subtract 6x on both sides. I'm left with 6y equals -6x plus 18. And divide by 6 on both sides. We're left with y equals -x plus beautiful 3. They should all be recalled. Okay, now these are linear equations, guys. We're gonna go ahead and do power 2. Power 2.